Yeah, thanks a lot for the introduction. So I want to talk about common issues in location data we have to overcome to actually build products we can use for good. So, but before I come to that, very briefly about me. I'm Benjamin, a data scientist at Unicast, but I actually come a long way from academia. So I actually started out as a sports scientist and then switched to neuroscience, worked 2 years as a postdoc for neuroscience, and then decided to go to industry. And now I'm very happy that I was able to join the Unicast family. So what are we doing at Unicast? So basically we have vision. And we try to get a deeper understanding of how people move and interact in the real world or in the physical world. Because we see that there are a lot of products out there which are based on social media or on the internet. And we believe that we are living in the physical world, so we also need to understand that. And that helps us to improve products and help in having better data-driven decisions. So what we try to do is to build what we call the real-world graph. So what is the real-world graph? It's basically a database where you can mix basically a product like a neighborhood insights with a foot traffic or a metric and a location. So what does it mean? For instance, you can take a location at any point and where you're interested in, and you can, for instance, inspect certain metrics like foot traffic, like visitation to certain areas, and so on. So what you can see, that's basically what we are trying to build. That's what the real-world graph is. But you can imagine that this comes with a huge limitation, and the limitation is the data. Because imagine you have a fairly small area you're interested in. If you only see a couple of devices in that area, it basically means that you have not that much intel, right? So therefore, we work with a lot of data. And what we do with that data is very simply put here. So it's basically the processing pipeline we have in a very simple way, and we are working on mobile data from devices, so raw GPS data. And what we do, we clean and pre-process the data, we aggregate it to a product, and this product goes into the real-world graph. And the nice thing is, although we have a lot of data, BigQuery is an amazing tool which allows us to do all those things. So what are those aggregated products I'm talking about? What's maybe something you have heard of is the Social Distancing Scoreboard. This has become quite popular lately, and it's a very, very interesting scoreboard where you basically can choose any county or state in the US and see how this behaved in terms of social distancing since the beginning of 2020. So it shows you a school grading system, but it also comes with different metrics, like, for instance, the average distance traveled in an area, or the visitation to non-essential stores, or, for instance, the average encounters of humans in an area. And so basically, you can investigate your county of interest or your state, and then you see something like gray bars, which are the reported incidents of COVID-19 in that area. But especially what you also see is, for instance, here depicted the average mobility for that area. So you see how it started at the beginning and how it went down with COVID-19. It then, at some point, there was a tendency to recovery, so it went up again. But we can also see that it never completely recovered. So, and you can inspect this also for different metrics and different areas. And we like this product a lot because it shows how you can use location data for good cause and help society. And we are very glad that this had quite an impact in several cases. So more than 10 million visits were made since the launching of this product to our website, where you can just inspect the data. But there were a lot of newspapers covering that data, or even used it in a forecasting. So instead of a weather forecast, it was a social distancing forecast in television. But what I actually like the most is that this data is used even for high impact publications in science. So coming from academia, that makes me very glad, and we are all very proud about this product. The problem is just, how do we build such a product? So if you're interested in using location data for good and build a product, you have to overcome certain issues. And today I want to talk about those issues. So if we talk about our processing pipeline, the cleaning and pre-processing of this location data is extremely important. So why is that the case? A common issue is, let's say you're interested in a piano bar here, and you see the orange dots here are certain devices, mobile devices, and that is fine. But what can also happen that you have the same behavioral truth, so that the same people are in the piano bar, but you see the devices somewhere else. That is because GPS accuracy can switch, but also GPS is shielded in kind of way inside of buildings, right? So we cannot trust this GPS location entirely. On top of that, we can have supply issues. For instance, that here for the state of New York, we have a much higher density for data compared to Pennsylvania over here. So that is a huge problem, right? So in certain areas, you see more devices and others less, but not based on behavior. So that is why we cannot trust the signal density entirely in the spatial domain. Let's inspect this in the time domain. And we have similar issues here. So if we inspect the piano bar again, it could be that on day one, it looks like this, but on day two, it looks like this with the same behavioral truth. The reason is why it looks like this could be that people just left their phone at home, or they're not using their phone in the bar, or some other reasons. So even here, in terms of from day one to day two, we will see differences. And to come back to the data supply, also that can change over time. So it could be that on day one, we have this issue between areas and supply, but on the next day, it could be all fine and gone. So we have also here the situation that we cannot trust the location data density and supply over time. There are many more issues and many more reasons why this actually happens. But what is very important here to say that this is not only behavioral, it also has technical issues. For instance, if the provider network changes, so you have onboard a new provider, so you have more data, that of course affects your data. Or you have a growth in apps. So the more apps are out there, the more likely it is that there's more data, right? But also changes in the operating system or system outages affect those things a lot. And how does this look like in data? So you see here data, aggregated data for the state of New York. And down here, you see aggregated data for the District of Columbia. And what you can see is that for the District of Columbia, it goes down over the years. So it's the whole time detrending, right? And that's different from New York, where it's more stable. But in New York, suddenly it has this ups and down. It's basically, it has the timely issue here. So there's a spatial difference between New York and Columbia. But also over time, we see sudden drops and certain trends. And what makes this even worse, actually, is that some of those ups and downs we see here are pure technical supply problems. So something we don't want to see, something we have to correct for. But we also have the same drops even in bigger amplitude on this side here, which is due to COVID-19. So we have to make sure that we preserve the behavioral part of it. And what makes this also very tricky is that it's very hard to find ground truth for that. It's almost impossible. We have no exactly ground truth. So that makes it very hard to work with this data. And there are a lot of issues we have to overcome. So what are we doing? So let's say you have location data and you see those issues and you want to overcome. One thing what we are doing approach is first, so we basically use different approaches, but what we do first is a blind source separation. A blind source separation is nothing else than an algorithm which basically takes your source or your signals and feature and puts them into or separates those into different components. So a common example is the cocktail party phenomenon. You have a room with two people talking over here, and you have two microphones in the corner of the room. And each microphone itself has an overlap of both voices, right? It's recording the noise of the room. But if you put those two signals of the microphones into a blind source separation, you get, in theory, independent components, where each component is describing the individual person in the room talking, right? And what we do on top of that, we use those independent components and move those or put those into an outlier detection, because we want to find the outliers in that signal. I don't want to go too much into detail here, but I want to show you a little bit more what is happening in the back. So there are many forms of blind source separation. You have heard of principal component analysis, independent component analysis, empirical mode decomposition. There's a lot of stuff happening. So what we are using is single value decomposition. And it's not important that you understand all the details here. The important thing is that we have a matrix of features and sources which we want to separate. We put them into the SVD, and it does 3 steps. It does a rotation over here, it does a scaling, and it does another rotation. And the important part is what you get out are independent components. So those components here are not that meaningful now. What I want to show you here is that when you put data in, you, for instance, get a component which shows those spikes here, which could be, for instance, holiday behavior. But in a different component, you don't see those spikes, but you see an upwards trend here at the end, which you don't see in the other components. And of course, there's always a component which is mostly describing noise. So that is the first approach, what we are doing. But what can we do now with those components, which are still not 100% meaningful? We can basically put them in an outlier detection. So we can plot all this data in an n component space, so where each axis describes one of those independent components. And you can then basically plot the whole data here and put or basically calculate the centroid of this n-dimensional cloud space, because we believe that the majority of our data, and especially in the component space, should still represent some behavioral pattern, meaning that everything which is far away or very far away from the centroid of the cloud is something where we believe, that might not be 100% behavioral. This is something we want to correct for on that side here. And that's simply put, that's what we are doing. We are calculating those based on the component. We're calculating those outliers over here. And based on this information, we create multiplications or basically a correction factors, which we use then to multiply the data and scale the data up, which is depicted here on that side. So how does it look like? This is the data I showed you before for New York here, and we still see the timely issue here, but we also don't want to correct for the COVID-19 period on that end. And to make sure that we correct for the spatial domain, what we are doing, we create this correction based on each area. So we are not throwing everything, the whole US, for instance, into those algorithms. We do it on a spatial level for each region independently. And if we do that, we basically, you can see here in green now, how it automatically corrects the data. And that's really nice, because here we saw this huge detrending and up and down period for New York, which is mostly gone. And the most important thing here for us is actually that we still preserve the pattern of COVID-19 period, which is what we want to keep. And that is pretty amazing, because there's absolutely no manual work. It's completely automatized on that end. So what can we use this data for? We basically use this first, the cleaning and pre-processing, to correct the data, right? Because we have certain use cases, especially if it comes to data for good. It's very important that we correct the data and that we have useful data and clean data, because they're sometimes it has a major impact on society. So it's very important that we take care of that. So the aggregated products then we create are cleaned and pre-processed and go into our real-world graph. I showed you already the social distancing score, which is used a lot, where you can basically check for your own area of interest how basically that area behaved since COVID-19 for certain visitations, encounters, or average mobility. But you can also go to our website and check, for instance, certain brands. You can check how, for instance, the wellness and fitness industry has changed or has been hit by COVID-19 since the beginning of 2020. So you get useful information, how it has recovered or not recovered, and also can inspect those for certain states in the US. But what we also offer is what we call the neighborhood insights. You can basically just draw on a map your area of interest, something you are interested in, for instance, Soho or a different area. and you get immediately statistics about those, like the average footfall in that area, or the most visited stores and those things. So those are pretty amazing products which can build on location data. And to make this work, it's, from our perspective, very important to take care of cleaning and pre-processing that data, because then it really can have an impact. So I really like to thank the whole Unicast team for the great work together, all our partners, but especially you for joining that talk.
Thank you very much, Ben. I'm not sure we have any questions on the chat. Oh, here we go. We do have a question on chat here. I'm not sure this is targeted for you, though. Well, either way, we're actually running slightly over time for the Q&A, Ben. So if anybody wants to talk to you, can they talk to you on the Unicast booth in the expo section?
Yeah, that's fine.
Fantastic, awesome, and feel free to. Oh, here we do have a question. Let's squeeze in one. So Benjamin from Raffaele Pranzo, did it happen to you to bump into any particular location noise in the data flow within the COVID period in itself?
I'm not sure what you mean in detail. So what we definitely see is, of course, due to COVID-19, we see a drop in mobility, and that also means that in certain areas we have less data, right? So that basically means that those areas we cannot use, because if you don't see certain areas anymore, it's very hard to use this data, right? So that's definitely a problem. And we also see that certain statistics change, that people stay more at home, of course, but also certain things that at the beginning of COVID-19, there was a huge hit, so the data changed a lot, and later there was a more slowly recovery, not from one day to the next. But not that we have like a certain variance in the data, no.
Okay. Benjamin, this is a question we've had through on Twitter. I just realized we are actually running ahead of time. There's so many screens and times going on there. Question would be, which kind of industries are starting to use this data the most at the moment? You touched on some of them in your presentation, but what are the recurring use cases in industry that you see?
So in industry, what is really used a lot is, for instance, retailers or real estate. This is right now where it's probably used the most, I would say. But it also is, becomes more and more popular in other areas. But right now, I would say retail and the real estate industry is probably the one which uses this the most in the industry part. But of course, we have a huge data for good program where it's mostly used, for instance, for universities for statistical use case and research.
And in retail and real estate, oh, we do have a question here from Elliot Kurtz. So are data corrections applied to GPS signals directly or to the area aggregations?
Yeah, they're based on the area. So it's not, so they're in fact, they are applied to the individual signal, but it's based on the area. So we are using, everything will be aggregated inside of a certain area.
Okay, fantastic. Well, that answers the first question that we had here. We have a question from Jamie, who spoke earlier. Have you started working with architects or city planners at all with this data?
Yes, not directly. So also with different data. So it's I today only talked about GPS data, but we also have collaborations with telco data where this is used for city planning. Yes.
Fantastic. And then Francesco Bertoli asks, you said you run SVD on time series, if I got it right, but then you talked about outliers in terms of days. Do you describe the days using the value for the time series obtained using SVD?
So it's basically, yeah, so it's not based on a single day, so we basically take the history into account. So for the SVD, the time series data or the features times time go into the SVD, and those components then are still based with the history. So it's not a single day going in. That is important because we believe that basically the history of the data is very important to show the behavioral pattern.
Right. Okay. Thank you for explaining for Francesco there. The question has come up, which always does come up with the mobile data around privacy. So how does Unicast deal with privacy concerns?
Yeah, I think it's a very important question, and that's why it's always good that it comes along, actually. So basically, there are different layers. So one, of course, is the legal part of, for instance, GDPR and Europe, or CCPR and other things. But we do more than that, because we say that we need to be strict, because privacy is a very important part. One thing is going to aggregated products, because in aggregated products, it's the privacy concern is a bit less, but it's still there. Because imagine aggregated products based on schools or religion or other things. So there's this privacy is not gone; it's still there. This is why we also, on top of that, have an ethics committee. So basically, that it's for us very important that kind of the people who work in the company, who are part of the ethics committee, can basically vote for what we do not want to do. And yeah, so it's basically several layers where we say that privacy is more important than every deal.
Fantastic. Sophie Eiling also has a question here. Could you describe a bit more about the grading system you created for social distancing? Was the grade based on compliance?
And so the grading system was based on those metrics I showed. So we basically have 3 metrics: the average distance, the visitation to non-essential stores, and the human encounters. And based on that, we calculated a baseline before COVID-19. And the grading system was based on the percentage drop based on those metrics. So you can, the details are actually on the webpage underneath the social distancing scoreboard, so you can look it up and see how each grade is defined. But it's basically very simple. So it's the percentage change towards the baseline before COVID-19 on those metrics.
Fantastic. That should answer Sophie's question. Awesome. And John has shared a link in the chat in case you're wanting to have a look at that. I think we've got another question here from Leo Just. So you're using correlation based on aggregated area in different periods. I think we actually answered that, so that's all good. Fantastic. Another question, Benjamin, for my curiosity is, have you had any engagement with governments for using this to inform policy making, and who is it typically in the governments that would be using this kind of data?
So this data here I presented today, the social distancing scoreboard, has in fact been used there. But I must say that I don't know the details, to be honest. So that probably I'm too much on the technical side to know those things. Yeah.
Okay. Well, I'm sure that they can ask the Unicast team on the booth.
Yeah, definitely. Always just drop a mail or yeah.
Fantastic. Awesome. Okay. Well, no more questions for now, Ben. So we'll say thank you very much for joining us today and sharing the story of the social distancing scoreboard. It's definitely fascinating and amazing work that you guys have done this year around COVID. So thanks for joining us, and we'll see you soon.
Thank you very much. Bye.